Hey everybody, welcome to another video. Just wanted to show you something really cool I've been working on and hopefully you can use it in your projects. So essentially what we have here is a water caustic shader, but what makes it really special is that it uses volumetric textures in order to seamlessly blend around objects, and also it enables it to react to the sunlight direction. So you can see here as I change the time of day, depending on the angle of the sun, the caustics react accordingly. And they also only show up on surfaces that are angled in such a way that they could be hit by the sun. It also makes it so that you effectively get basically no visible tiling. Here you can see if we get down below, caustics are reacting to the surface normals of the objects and showing in the top but not on the bottom side, and that again changes with the angle of the sun. So you can see as the sun moves, so does the angle that the caustics will be displayed on. So first thing is probably to answer the question as to why volumetric textures. So if we go over here, we've got a couple of different setups. On the left is a standard flip book, and what you'll notice is that it doesn't matter what angle the animation is playing from, you get the same look on all sides. You might get this through triplanar mapping or something along that line where the effect looks the same from all directions, which isn't very convincing. Here on the right, you have another really common way of handling caustics, which is to, rather than using a flip book, just pan some UVs, maybe do some distortions with normal maps. But again, not very convincing and has all the same problems, just a different way of achieving an animation. Here in the middle is the volumetric texture, and the advantage here is that you can essentially get an animation just like with a flip book by panning through the Z dimension of your texture, and it will seamlessly blend on all sides. So let's go back over here, and well, actually let's take a look at this. So this is the same setup with a SingleLayerWater material, well, heavily simplified version. Just one thing I wanted to mention about SingleLayerWater. So SingleLayerWater materials don't have the ability to sample world normals directly. You can derive the normals, and we might talk more about that later, but you do get a faceted look. So you can see here as the normal blends the caustics out on the other underside of the sphere. It's not a smooth transition. So if you are using this with the SingleLayerWater material, I would suggest maybe using a decal. So here on the right hand side, I've got a decal with just kind of a UVW grid on it, but you can see that it is able to pick up the pixel normals. So one way you could, rather than applying the caustic effect to the water material like I have over here with the translucent shader with the SingleLayerWater material, you might want to do that in a decal or in post-processing or something. Ultimately, this effect can be achieved in decals, post-processing, and on the surface shader. So it's really flexible, and you can do whatever is appropriate for your project here. So in this example here, this is on the surface shader. The consideration there is that with that, as you pass into the through the surface, you will not see the effect because it's actually on the surface itself. So you might need to add a post-process or decal for when you're underwater, or it would be appropriate for content where you're viewing it from above and not actually going into the water. Whereas when you're using the decal method, if I go into this single layer water here, you can see that the decal is still there. So a couple of other notes: surface shader, when you're looking at reflections, such as in Lumen here, that isn't going to be picked up because it is on the reflection. Whereas if you have a decal, so say for example I move a decal in here, you can see that as long as a screen trace can be made, the decal will be picked up by reflections. So if that's important to you, you can get reflections of your caustics, but it doesn't seem like that's particularly necessary, but it is screen space. So if as I move the decal off the screen, you can see that it disappears from the reflection. So it's not without its flaws, but it's one way of handling things. So how does this actually work? It's fairly simple, but you can make it pretty complicated. So here, for example, is a volume material for caustics, and you can see it's kind of this wispy, smoky look, right? And so each slice of this is essentially what's being projected against the ground of the texture or the walls or whatever. But when you're looking at a ground surface, for example, when the sun's at a high angle, you're primarily looking at a slice from this direction. And then when you're looking at the walls, you're primarily looking at slices in this direction. So let me hop over here. So here's a post-process material, and you can see that essentially what we've got here is an absolute world position node, and that is going into our texture sample. Just divided it here for the purpose of scaling it, and that is being pumped out into the emissive. And essentially what this is doing is it's just saying, all right, well, here's the world position, sample the texture, and then display it. All right, so it's really, really simple at its core. And that's the same basic concept that we are doing in all of the versions. But where things get complicated is when you want to start adding special effects, like, for example, having it change based off of the angle of the sun. So if we go over to the actual material, so here's the one that is on display here. There's quite a lot going on, but when you are sampling a translucent material or a single layer water material, this is going to be key. So I'm just going to go ahead and hop over to a new material, and we'll talk a little bit about this. So this is not necessary for a post-process volume, but you will need it for transparent surfaces. So essentially what this is going to do is create world positions behind the surface of the water, and the way it's going to do that is by essentially looking at the depth and multiplying it by the world position. It's a fairly well-known technique. There's actually a pre-built node that does this, but it's really pretty simple. So you can see that when we take the output of this, we essentially get a world space UV. So we can just take that, and just like in a post-process volume that I showed you earlier, we can take the world position and use it to sample a volume texture. So as we get this, let's probably throw back in that divide you really do need. something to scale this by most of the time, but it depends obviously on how your stuff is authored. So here we can see we've got a texture going on. And so I'm just going to go ahead and throw this material on, oops, on my mesh here. Apply this. You'll see already we've got something going on, right? So we have the basic idea working here. Along the sides, we've got our volume stretching along its vertical axis, and on the surfaces from above, we are seeing it projected from the top. And you can scale this in 3 dimensions. So you can divide. Let's convert this to a parameter, for example, and say maybe if we want 100, 100, and maybe only, say, for example, 50 in Z, and now we've scaled that, right? So we can actually control that. So let's go with, I don't know, 30. And then let's also go ahead and tone down the strength of this as it's kind of overwhelming. All right. So we're off to a good start. So you can see that it's projecting down on top of the surface, which is cool. So the next thing that we can do is talk about, I would say, the sun angle, right? So in this here, what we're doing is we've got our atmosphere sunlight vector, and we've got our scene texture world normal, and we are taking the dot product. So we take a look at this. See here that as I remove the sun around, we get the dot product, and we can use that as a mask. So let's use that to lerp between our final output here and nothing. So when we do that, you'll see we have our caustics now being canceled out by the shadows. It's not perfect in the sense that if, for example, I put this on this side, right, and realistically you would get a shadowing part here, and depending on how deep the water is, but obviously it doesn't actually have access to the shadow information, but we can at least block out walls that would not realistically have as much caustics on it from receiving. And you can control this effect, right? So you might not want it to be this strong. You can let the light bleed over the slope a little bit more and get some caustics kind of running down the backside. But I think this is good for our purpose here. All right, so we are just taking a scene texture, and then we go and we grab the world normal. And this is, again, where you're going to have a hard time with SingleLayerWater, because SingleLayerWater does not have access to the world normal, but it does have access to a sampler, let's see, called world normal behind water. But again, just like I mentioned earlier, this is going to give you this faceted look. It's not going to be a smooth normal, so you might not want to handle it in that specific way. But it works okay, especially, again, if you are looking at the water primarily from above, and because of that, you aren't really going to see the back side of objects where that masking is happening all that much, but just something to think about. So the next thing we should probably do is maybe scale, or not scale, but rather pan this in the Z dimension like I mentioned. So we can simply go in, throw in an add. We're going to make float 3. Let's grab time. Just now do that. We go ahead and apply that. What's happening here is you can see in the Z dimension, it's scrolling, and that's causing it to be animated on our water floor. But on the side, we get this kind of weird looking effect there because it's not moving at all, right? So what we probably want to do is also pan our X and Y slightly. And let's maybe do it by a lower amount than our Z. We don't want to correct that. Be even less. And now we essentially have things looking a lot like what we want. But as you can see in this current form, there's a decent amount of tiling. Part of that's because of the scale that I've got here. If I were to that up, we would see less tiling. That's not so bad right now. What I did here in this version is I also modulated that Z position by a noise texture so that as it pans across here, it's not the same Z position across the whole span, which added even more variation to it. So that's one option that you can do. And that's just, again, a texture sample that's going into the Z panning here, or the Z offset. And, you just control how strong you want that to be and so on. And let's see. Another really big piece of the shader, again, is getting it to rotate to face the angle of the sun. So if we go ahead and erase this and talk about it for a minute, what we have here is a rotate about axis node, which is going to take a world position, which we have right here, right? So you take that world position and you rotate it around a pivot point, which sphere sun vector. So what we have going on here is the atmosphere sun vector is going to be pointing in, let's see if I can show it. It's off in the corner. All right, well, any case, we'll use this as an example, right? So we have the atmosphere sun vector, and if it's pointing straight up, right, it's pointing in that direction. And if we just rotate it around our atmosphere vector, we would spin our caustics around in a circle, which isn't really what we want to do, right? We want to rotate it along the angle that's perpendicular to the sunlight vector. So what we're going to do in order to get that is we'll take our sunlight vector, and I've just found that in a lot of places it's backwards. So I'm multiplying it by 1, 1, negative 1 to flip the vector around. And then we're going to take the cross product of the upward facing normal. And what this is going to do is it's going to give us a vector that is perpendicular both to the upward facing normal and our sunlight vector. And that will give us, because because the only vectors that are perpendicular to the upward facing normal are, in this case, planar to the ground. When we take our perpendicular, when we go to find a vector that's perpendicular to our sunlight vector, it must also be planar to the ground, which will get us rotating around the horizontal perpendicular vector of the sunlight, right? So we take that as a cross product in order to find that. We'll normalize it for good measure and put it into the rotation axis. For the rotation angle, if I just maybe just go ahead and add this in, and then we'll add a scalar here for the rotation angle. You'll see is that as I move the scalar, we are rotating, right? So as I go to 0.5, it's now perpendicular, or excuse me, it's now rotated all the way around. At 0.25, yeah, so at 0.25 it is perpendicular. So now the ground is receiving the side edge, and the walls are getting the face, right? So basically, I guess what I'm getting at is 0.25 is our 180-degree rotation point. So what that tells us we need to do is when we are finding our angle, we're finding the angle between the sunlight vector and, again, our blue vector, our upward-facing normal. We get the dot product. And if 0.25 is going to be our 180 degrees, we're going to add 1 to remap that into 0 to 1 space instead of, we're going to add 1 to the normal, so it's not going to be in any negative space. And then we're going to divide that by 4 and map that into our rotation angle. And so what that'll give us now is, as our sun gets to the 180-degree angle, we are going to get that 0.25 output that we saw. And this will allow us to get the rotation so you can really see what's going on here without all the extra effects. So this is probably the coolest thing in the shader that I think really sets it apart. Once you combine this with the normal masking, based off of the pixel normals to get that fall off here on the edge, this is the majority of the work done. So the next thing that we can talk about is, and also just pivot points 0 on that. Next thing we can talk about is the, let's do this stuff here, sun angle and the water line, right? So as it currently stands, this caustics effect is going right up to the edge of our water, and in fact, if we get down below, you'll see it's actually even projecting it up above. So if this was, if we had a something above the water like this, this shouldn't be getting a projection, but it does. That's because this is just projecting it everywhere in the world. In fact, if you can look out over here, you can see it's being projected everywhere. When you're dealing with water, this isn't an issue because you're only ever going to expect to see the caustics down through the areas that it's projecting onto. So you're not going to get this kind of fish tank situation in most practical applications. So, just another side note here, this particular caustics texture is in the engine content if you activate the water plugin. So you can make your own. There's a caustics generator that you can use to create them, but there's actually a pretty good one if you activate that plugin. This one here is in the base engine without the plugin, but it is not tiling. It looks okay for testing purposes, so if you don't want to activate the plugin and you just want something to test this with, then you can find the existing volume texture flipbook. And any tiling flipbook or any flipbook caustic can be converted into a volume texture. You just create a new volume texture by going here and then say volume texture, and then you select the texture asset and choose the the tile sizes. And so flipbooks are going to have the exact same composition essentially as a volume texture. So they're you can use those already authored assets to convert them into usable caustics. So going back to this here, we are masking caustics at low sun angles. So what this is doing is it's just saying, again, from that same dot product, it's going to take subtraction from it. So as the sun gets, kind of to these extreme angles, the effect doesn't really look that good anymore, right? Because realistically, if the sun was on the horizon, it's not going to be able to refract much of that light down into the water, and definitely not at these angles. So we can essentially use that to lerp out our effect. Right. So if we just grab this, we're once again going to grab that dot product, and this sun angle fade parameter here, I have just controls how much that subtracts, right? So that's a value that I found works pretty well. And you can see here, it gets rid of it. And as I change that parameter, it will control how much sun is getting through at that angle. And as I change the angle here, it will darken it, so you can see that happening. So what I typically would do here is find kind of a point where I would expect it to start fading out, and then find a level that more or less gets rid of it at that point. So I know that as it gets at a lower angle than that, it's going to be gone. And I found that 1.3, negative 1.3 works well for this. So we can see that going on there. So next here is the water line, as I mentioned. So essentially what we need to do is go back to our world position. So again, this is our world position. So we're going to grab that, and we're going to mask the Z component, or B. And then from there, we are going to, let's into our missive here so we can see it. You can see what's happening here is we have a control of this point, which is just subtracting from the mask of our world position. So, at whatever value you want that to fade in, you can do that. And then the division here will control the range of the effect. And there's a lot of different ways that you can control this. So something that works for you. In fact, this doesn't seem to be working like I intended right now, but that's okay. In any case, what we're going to do is use this as yet another lerp. Once again, mask out our emissives. And if we go ahead and apply this, you can see that we are not getting any emission above the water line anymore. And we can control that fade. So you can customize those controls to your liking, but that's the basic idea, is just to get a bit of a fade from the top of the water, and you can play with that to find levels that you like. The next thing here is this is just the normal map to make the water animation. So that's nothing special, just taking two normals and panning them in opposite directions. Here's some refraction. We'll talk more about that later. Then we have the opacity values, the watercolor. So with standard translucent materials, you're gonna generally choose a base color that you like and set an opacity. And again, this is a translucent material here. So, and then we probably need to increase the strength of our effect here so we can still see it. But now let's keep it a little flatter for the purpose of this. So that pretty much covers all the basics of the effect, right? You want to have some masks to control where it shows up, where it doesn't, so it's not projecting everywhere. You can have it fall off by depth. And a side note for SingleLayerWater, if you are working on SingleLayerWater, instead of scene depth, we'll need scene depth without water, which does the same thing, but it will allow you to get the depth behind the surface like we see here on the SingleLayerWater version. So minor difference, but yeah, so that's pretty much all the important stuff. And going back to refraction, one important thing to note here is if we go ahead and just throw this on, and this is just a scene depth. One thing I wanted to bring up is that whenever you're using refraction with anything that is sampling scene UVs, the scene UVs are not distorted. So you can see here that the refraction is actually not distorting the depth sample. So we have this silhouette that doesn't line up, and the higher your index of refraction is, the worse this misalignment is going to be. If you keep your refraction at sane values and use it responsibly here, you can see that it doesn't really even it's not really visible. I don't think anybody would notice. If there's enough demand, I can make a video that covers how to build in refraction to manually refract your scene UVs so that this will get seamless response to refraction, or just anytime you need to sample depth, you can refract it and get it to match what the engine is doing with its native refraction. It's not particularly easy or cheap, but if there's enough demand for it, then I could set something up like that. So yeah, I think that just about covers it. Outside of that, you would just set up your water material like normal, right? So set up your normal maps, your color. If you're using SingleLayerWater, if we bring up SingleLayerWater, set up your scattering and absorption. You can see this. It's all fundamentally the same thing here. You can see scene depth with water. So there's two ways you can handle it. Again, there's the normal behind water node here that is going to give you pretty good results. That's what this is using right here. And you can also take your DDX and so if I pull this up, you can see it's quite a bit going on here, but nothing crazy. It's just taking multiple samples and comparing them. But another option we can do is take our DDX and DDY of our world position, take our cross product, and normalize it, and that will get us normals as well, but they are not going to be quite as high quality, but we can still see the effect does work. So that's a cheap, easy way to get normals behind your SingleLayerWater if you need to. Yeah, I think that's really all there is to it. If you have any comments, anything that you want to add, any criticisms, again, let me know if you want to see more about how to compensate for refraction. Just throw it down in the comments, and hopefully you find this useful. Thanks so much for watching.